Greetings, everyone, and welcome to the Complexity Lounge, a meetup where we gather to talk about all things related to complexity and complex adaptive systems. I'm Jocko Selberg, and I co-host the lounge together with Barbara Frontera and Tiani Jones. Today, we welcome John Willis to the Complexity Lounge. John is an accomplished IT management expert with over 45 years of experience. His extensive body of work includes the book Deming's Journey to Profound Knowledge, as well as co-authoring the DevOps Handbook. And he has recently released a new book on the history of artificial intelligence titled Rebels of Reason. And he also hosts an excellent podcast called Profound. John, welcome to the Complexity Lounge.
Great. Well, thank you so much. Thank you, Barbara. Thank you, Tiana. Yeah, it's really awesome to be here, honestly. Any sort of lounge that has the word complexity in it is like kind of a place I should probably be more often. Okay, so there's a lot here. It's actually if you're into aesthetics of slides, you're in the wrong place because this is like I was digging through all my different presentations I've done over the many years, and each time I was trying to put together, okay, well, how do I tell this narrative of Deming's system profound knowledge, which is really going to be the core of this, and how it applies to how do we think about it in AI? Now, I'll warn you, we're not going to get to the AI stuff until a little later in this discussion, with the point being that we literally want to sort of understand Deming's sort of what I would say universal thoughts on put anything on it, quantum, if you will. I think these principles have applied, from as early as 1925 into 2025 and beyond. So there we go. Let's see what we got. Okay, so introduction. I'll tell you a little about my journey. My name is John Willis, but I picked this goofy name back, who knows, many years ago called Botchagalupe. Some ways it's worked out well, in other ways it's been just terrible. But I'll talk about my journey, and then we'll go into like who is Deming, basic. And then I think the really important part before we get into AI is you have to understand Deming. And I think that there's a lot of people say, oh, we tried Deming and it just didn't work, or people say, like Deming was never a manager, and oh, therefore, how does he be manager? Or the sort of like the people would ask. Actually, some people complain at Deming. He wouldn't tell you how. Like he wouldn't tell you what to do specifically. In fact, there was one time, he sort of chastised a student because the student was like asking all these questions, and Deming loved questions, but like if you sort of like at one point he says, "Do you want me to teach you and do your job?" And so one of the problems with Deming is like he didn't. He was what did they say? He didn't suffer fools well, and to him, like it was sort of very clear about like let's focus on what we have to do to learn together. Anyway, so understanding Deming is an art, is something. And then we'll get into the AI stuff, and I'll tell you a story about my book and how it applies to this idea, which is the epilogue in the book, The Philosophy of AI, and where that came from. And we definitely can open up a discussion. Done many books, probably mostly known for the DevOps Handbook. The two I'm going to focus on in this presentation is the Deming's Journey to Profound Knowledge, and and then the Rebels of Reason, which is really sort of a history of AI. And I'm actually Thursday. I'm officially starting my 14th book, which is going to be fun. I now found that this idea of like storytelling technology history is I love this, and so I'm actually starting a book about the history of quantum computing, and it's just already been ridiculously fascinating. So again, my profound knowledge and roles. What I like to say is sort of like how would Michael Lewis write a book about sort of modern day technology, or how would Michael Lewis write a book about the history of AI? I've done a couple other books. We'll talk about something called Beyond the Phoenix Project, and yeah, there they are. And just a little bit about me, in case you don't know who I am. I've done sort of like I sort of hate the question when somebody asks like, John, what do you do? I'm like, yeah, I don't know how to answer that question because I do a lot, and like today I think I mostly answer I'm an author. But I've held executive roles at Exxon, Red Hat. I sold a company to Dell. I've actually had 12 startups, most of them miserable, like devastating move into the basement of my brother-in-law's house. Terrible. But I've had 5 exits and done about 4 startups. I sold a company to Docker. I was one of the original cloud evangelists with Canonical, Ubuntu Enterprise Cloud, which was one of the first private clouds. I've done a fair amount of work with MongoDB on their AI vector database, and currently I'm with a company called Liatrio, which is I've advised for them many years. I'm loving this idea of like people are starting to figure out how to do DevOps and AI in the right way. And if you've read the Dora report, I won't digress too far, but the Dora report really tells the narrative. Like the people who are succeeding in AI are the people who've always succeeded because they're doing it. They're doing it with the principles that you need to do. And the people who are failing at AI are the ones who are not like they're thinking this is a new flash in a pan thing. So the other thing I wanted to start with is this set of baseline on terminology. A couple of things. You know, I'd we talked about a little of this before we started. Is like if you ask, you put 10 people in a room on system thinking, you're probably going to create a Donnybrook. I think the same thing with complexity. So I was going to just say, I'm going to go through Deming's sort of interpretation and what he would say and what he had said about these concepts. But I don't think it'll be actually very fruitful for us to argue over, whose version of systems thinking. I like the joke Jay Blue says on Kinevin, like, the first rule of the Kinevin Fight Club is you don't talk about Kinevin, right? So the first rule of this Fight Club or the Deming Fight Club is don't try to argue over systems thinking or complexity. All right, so let's start with this. This is my book on it's called Deming's Journey of Profound Knowledge. And so let's talk about Deming for a minute. So Deming, born in 1900, he basically his professional career was 75 years. And to put it in perspective, we'll talk about some of his accomplishments, but like at 50, he is today great. Today he was noted for his greatest accomplishment was something that happened when he was 50 years old, and we'll talk about that. That's going over to Japan after World War II. Um, at 93, he writes his manifesto, which is called The System of Profound Knowledge. At 80, between 80 and 90, he does the most, excuse the pun, profound work, not only of his career, of most people who have ever sort of done any kind of management. In from 80 to 90, I don't know I don't think I'll be here in 80, but like just put that in perspective, right? So and I'll tell you the story how I got into Dr. Deming a little bit, but when I decided to write this book, I thought like there's about 20 books written about Deming and 20 that are reasonable, probably 10 that are worth reading, but they were almost cookie cutter. They're like, maybe 5, 10 pages about his biography, and then the rest about how do you solve all the world's problems with their interpretation of his ideas, which actually, by the way, most of them, I think Deming would be disgusted about. And there were really none. Most of them were written 20 years ago. Very few written within the last 10 years, and none of them talked about like what how Deming would think about lean, agile, DevOps, DevSecOps, SRE, all the things that I'm pretty passionate about, and I'm pretty sure most of you are. Like I said, I like the Michael Lewis storytelling, and so what given that this complexity allows, what we're going to really try to dive in is like, what did he think? What was his theories? What were his ideas? And how did they relate to complexity and systems thinking? And I did that in the book. And actually, one more thing about the book. Um, we'll talk about profound knowledge of what it is and how Deming thought of it as a tool to at least sort of understand complex systems. And I think Deming, along with everybody else, realized everything is a complex system. And so what I wanted to do is, unlike any of the other books, I wanted to figure out how did he pick this stuff up? He didn't just create his thoughts about system thinking that weren't just like he didn't create it. His thoughts about like psychology or epistemology. So I wanted the narrative, which was his journey of all these things that made up his life in a very storytelling way. So for me, it started with so to tell the backstory. I ran the first DevOps. I was at the first DevOps day in Ghent, and so I'm considered probably, if you sort of care about order of things, which I don't really care, but since I'm saying it, it sounds like I do care. Uh, people say Patrick DeBar is the godfather, and I will say if somebody calls me the godfather of DevOps, I'll say I'm the consigliere. But I was the only American at first DevOps days in Ghent, and I came back with my good friend Damon Edwards, and I said we got to run one of these in the U.S. So we ran one at LinkedIn in 2010, and Gene was on a panel with me, and I knew who Gene was. I knew of his work and all that, but I didn't recognize him. And after the panel, Damon came up to me and said, that was Gene Kim on the panel with you. I'm like, oh no, and I couldn't find him. So he agreed to meet at South by Southwest a little bit later. He told me about he was writing a book about the Phoenix. He wasn't called the Phoenix Project at that time. It had 10 names before he actually came up with the final name. But and one of the conversations we had, which was, he had this idea that there's probably going to have to be, because it was a novel, Phoenix Project was a novel, and there had to be sort of a handbook, because the novel's great for sort of like giving you sort of an idea, but the first question you ask when if we'll go back to Elliot Gorat, like the first question people ask with Goal is like, okay, how do I do TOC? You know, um, and the novel really doesn't tell you that. So we knew we had to write a DevOps handbook because we actually started that, um, and so I was down that path. And the other gift he gave me is I didn't know anything about Elliot Gorat, and so he told me before he would give me a copy of his book, or like he suggested before his whatever that book name was at that time, he told me I should read The Goal. And I read The Goal, and then I read It's Not Luck. I mean, I read like four. I would just like consume Gorat. Gorat was like, oh my God, like where's this guy been all my life? And I fell in love with him. And so and again, this has all become relevant, I think. But we were at the first U.S. DevOps days, no, second U.S. DevOps days. We ran a session on theory constraints. And I'm like, go at this and that. Come on, get out of my way. I'm going to go ahead and tell you everything I know. Um, Let me hit the OK button there. And so a friend of mine, Ben Rockwood, comes in and said, like Ben would never do this, but like he was sort of almost like patting me on the head, saying, "Oh, John, you're so cute." Um, it all goes back to Deming. I'm like, no, 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 go right, go right. It's like a little kid, no, give me a go right. And he's like, no, no, I'm telling you, it's Deming. And he challenged me. He said, go ahead and read his 14 points. Come back tomorrow and let's talk about this. And I did. And I was like, oh my God, yeah, no, I get it. And then that was the end, the beginning of the end, because I literally became sort of a sycophant on Deming. And so I worked out this idea. I got really lucky. Mark Burgess, who created, sort of Promise Theory and was the original sort of creator of infrastructure as code, was a friend of mine. And I started seeing that there was this thread of why were Gorat and Deming different than all the modern management theories that we could hear. And I sort of teased this idea that they both were physicists, in like the sort of the time, Deming a little older than Gorat, but literally at a time when sort of you know, uncertainty was becoming a really interesting conversation, right? Like, not just Einstein, but, Heisenberg's uncertainty principle. So, like, even though they weren't quantum mechanics or quantum physicists, they were clearly living in a time when, and so I started pulling that thread. My friend Mark Burgess, who was a physicist before he became a computer scientist, helped me get through all that hard stuff. And then at one point, I became so versed, and Gene got so tired of me talking about Deming, we agreed to do a book. So one of the things that Gorat wrote the Goal. 20 years later, he wrote Beyond the Goal, an audio-only book, and it's one of my favorite all time. I try to listen to it once a year. I think it's so important. And I approached Gene with this idea, like, why don't we do a Beyond the Phoenix Project? And so what we did is Gene covered Gorat. He covered how he wrote the Phoenix Project. I covered Deming. And then we sort of ended the book out with like what we call the three legs of a stool of DevOps: lean, safety, culture, and learning organization. So that's sort of my narrative of like how I got into Deming, and again, there was a lot of this sort of uncertainty. If you know Mark Burgess, Promise Theory is all about sort of uncertainty probabilities. Um, and so So anyway, and this is kind of cool. Like this, we all have these highlights of our career, and this is me and Gene in the studio for a couple of weeks recording the audio only. And it was, like I see the pictures and I sort of almost cry because it was just such a like. I've done a lot of stuff. I've sold companies. I've written books. I've been around the world. I'm not, sort of like trying not to say it as bragging, but like this was a top five. All right. So who is Dr. Deming? Um, you probably heard his quotes. Again, I think it's so obligatory to have a Deming quote in a DevOps presentation. That's a rule. But you've heard of all quality. And by the way, there's a whole kind of side story. A lot of these aren't his quotes. So like that's the one that's sort of disheartening. People are like everybody's quotes, right? Peter Drucker's quotes, right? They like when you go and find out the quotes are all sort of um, but they give you a sense of what he's about if you sort of read between the lines. Every system is perfectly designed to get the results it does. A bad system will beat a good person every time, right? So a lot of these, if you go back to his sort of two main books, um, you might have actually heard of his 14 points. Again, I think those are the things that was the hook for me. But the problem with the 14 points is like you sort of like, oh, this is great, this is great, this is great, this is great. What do I do? And what you have to understand as we break this down a little further is the 14 points are really more of the roadmap to accomplish his deeper theories. So if you understood that as a pattern, then you have a much better appreciation. Because I think if most people just read the 14 points, they go, well, that's a great one. That's a great one. That one happened to me. But you don't really, if you see it as this is sort of the rule book or the playbook for his other, profound principles, particularly system of profound knowledge. You probably, if you know a little bit more about Deming, he's sort of very famous for after World War II. We were challenged to help rebuild Japan. It was really that MacArthur just wanted to get electricity and roads, and nothing was working. I spend a lot of time. I really have some great stories in my book about how bad it was, what the war did to Japan. Or again in the storytelling vein, it's not just Deming was great and there's Deming this. It is a lot of sort of even how much he loved that culture. He fell in love with that culture. They fell in love with him. But then the general narrative is he created the miracle in Japan, which is poppycock. Japan created the miracle in Japan. Deming was a big influence. So was Duran. There were definitely other people who had serious impact. But Deming was not trivial. In fact, to the point where, as in 1950, there was a seminar that he gave in Mount Harkani, where they said that years later they estimated 80% of the wealth, the curling wealth in Japan, was in this meeting. And he told them, if you follow my principles, that in 5 years you'll be a world economic power. And in less than 5 years, they overtook Japan to be number two behind the United States. And here's the thing: if you read that speech, it's out on the Deming Institute. It's a system thinking. I mean, it is clearly a system thinking. It's basically telling them all these sort of companies not to, this now is not the time to compete with each other. You have to bound as a nation. And they awarded him with the Deming Prize again. Um, and then you probably also, if you know a little bit more, you might have been involved in stuff in like statistical process control, which came from Walter Shewett. We'll show some example of this later when we get into sort of more how do you think about how do you understand. This is really more about what Deming did. He introduced this for the first time so here's another example, or not example, I'm trying to, the conversation we had before this started, but one of the things that Deming was really good at is taking principles and making them, being able to fit them into other domains. So at this point, statistical art control, when Deming learned it, was really just manufacturing from Walter Shewett. Basically, Western Electric, Shewett was realizing there was a high defect rate, and so he came up with this really clever idea of using statistics and sampling and all these sort of techniques to get higher quality with less. In today's sort of version of it is not having 1,000 testers that you ship software over to, building the testing process into the process itself. probably TDD or BDD, those kind of things. But here's an example where he took those things that were purely manufacturing and actually changed everybody's life because he integrated that system into the Census Bureau. I think it was 1936, right? Saved them a ton of money, but more important, created a level of accuracy that they weren't getting sort of manually testing or sort of, and it actually, in my book, I cover like how that affects the Electoral College and, so to this day. And then, I think if you really, really were paying attention to Deming, you'd realize, or if you read my book, certainly you'd realize his impact on Toyota Production Systems, which then has clearly impact on Lean. Love or hate Six Sigma. I mean, like I can tell you all the ways I hate Lean, and I can tell you all the ways I love Lean. My wife was a black belt in Six Sigma at GE Capital. I was a green belt, but like that's nothing to brag about because they just give everybody a green belt. um, but the point is, there were things about it that were beautiful. And there are things, but I mean, more than sort of Lean, which is Six Sigma, was so dogmatic, and the people who tried to run it was just ruined it. And maybe in the end, it wasn't the right thing anyway. But, um, but so, and by the way, Deming hated Six Sigma, so there's another hole. And I've done Deming to DevOps presentations over the years. My book will sort of drive. Because one of the things I do in my book, The Deming Journey of Profound Knowledge, is he dies in 93. And there was a lot of cool stuff that happened from 93 to 2022, right? So I literally said, like, last third of my book is like, what would have Deming said about, like, sort of agile? What have he said about Lean? What would he said about DevOps? What have he said about, sort of cybersecurity, DevSecOps? So that's really the last part of my book. So, understanding Deming, right? So that was Deming, gave you a general. Now we get to sort of see like how do we understand him. So Deming was really a true polyglot. Polyglot in the sense that, if we use polyglot for not just language, but sometimes software language, or it's just something that has someone you basically fluent influence, of intellectual discipline or cultural languages. So he was a mathemat. He was trained as a mathematical physicist. He clearly could be considered an epistemologist. His business card said he was a statistician. He was definitely a professor. I think, like he wasn't a certified psychologist, but like clearly you'll see in a little bit his thoughts there. I think he's one of the original systems thinkers. I'll explain that. He was an agriculturalist. One of his first jobs were basically at USDA. And again, applying statistical process control at USDA early on, industrialist. And then I make the argument that he really was a DevOpsist and a futurist. So, but his direct influences, this is, and again, some of them are sort of the same time and some of them, but like when it comes to knowledge and epistemology, he was, he sort of, I don't know if he was joking or not, but he said he had to read C.I. Lewis's Mind in the World Order 6 times to understand it. See, I'm smarter than Deming because when I was writing my book, I figured if Deming would take 6 times to write it, I read it and understand it, it's probably going to take me 30 times. So what I did is I pulled a Tom Sawyer. I got Jay Blue to read it for me. And he explained it to me in the miraculous way that Jay is so awesome at explaining very complex. But that opened up the door to pragmatism. So I spent a lot of time talking about pragmatism in my book. And Peirce is so interesting. In fact, the bookend of this presentation could be Peirce, who is one of the fathers, not only the father of pragmatism, but the father of abductive reasoning. So stow that away a little bit because when we get into the philosophy of AI, it comes all the way full circle back to, I think, Peirce and the argument that you can make about where does AI fit in this nonsense of AGI, ASI. System thinking. So Deming, before the war, with Russell Ackoff, sat in on Burton Laffy's general systems theory presentation. So that had an enormous impact on Ackoff and Deming. Now, Ackoff went a lot further in explaining systems, but it both of them were sitting in the same webinar. And then just having in my book, I'm really clear about people could be incredibly successful and do a lot of things, but they still could be terrible people. Burton Affy was a Nazi, so and you could argue he got forced to go back to Germany, but a Nazi is a Nazi. And then And then so Peter Senge, there's the famous story where Peter Senge, the Fifth Discipline, Deming wrote in the second edition a whole letter for it. But the truth is they worked together. So in my book, I talk about a guy named John Warnock who worked at GM, who was a big fan of Deming, and they were trying to catch up to what Ford was doing in Deming's work. And I have a whole story. And so they brought in Senge and Deming. So this John Warnock knew Senge, knew Deming, and they brought him in to help them create motorsports. And motorsports was interesting because they had the problem was the executives at GM asked this John Warnock, how do we, catch up to Ford with what they're doing with Deming? And on the normal cycle of automobiles, it was sort of, minimum 5 years. And then they said, what about in motorsports? So they actually were able to, because motorsports, you can iterate really quick. So, anyways, really good story there. On analytical statistics, certainly Walter Shewett. I mean, he was the creator of SPC. But this is also again where I think it's really interesting if you sort of tease out 20th century science with Dr. Deming and sort of influence. Percy Bridgman created the idea of operational definitions or operationalization, so which is a big part of operations management and certainly in industrial engineering and supply chain. But it really, and I'll go a little deeper into this of how I think this is what Bridgman sort of influenced Deming and Shewett. And in psychology, there's a little bit of a loose directive, but it's very clear that McGregor's System Y and X fits Deming and then even Maslow. Um, so when we talk about complex systems, let's be clear that Deming used the complexity, didn't use the term complexity science. That terminology came later, but he repeatedly talked about complex systems. So I think in a general, depending as long as we don't get into the Deming Fight Club stuff, we're talking about the same thing. Same thing with system thinking as well. So Deming would say that, a system is a network of independent components working together in common aim. So Deming was very clear about this idea of aim, that you had to aim. If you've ever read Mike Rother's, he would call it the true north or right. And this sort of the aim is this sort of beautiful thing where like and I fundamentally believe that this was Toyota Production Systems core DNA. In other words, you can basically set a target, a true north. And Rother talks about this in his Toyota Kata book, right? That you can set a true north and it may not be achievable. But if you're always pointing in that direction, you're making progress. And then, this is very goal ratting-ish. And that without management of a system as a whole, the parts will optimize locally and destroy the system globally, right? Goldratt talks heavily about local versus global optima. And then there's a quote from one of his books. He had really two major books. He's written a lot of books, but most of them are like mathematical thesis books. He had a book called Out of the Crisis in 1980, and then he had a book that came out the year of his death called New Economics. And New Economics is where he describes system profound knowledge. He warned that complexity led to unintended consequences. I think nobody would disagree with that. If we manage the parts rather than the system. So if we look at sort of Deming's view, if you want to sort of put it in the table, nature of systems, everything's connected. Performance depends on interrelationships, limits of control, variation. So variation, again, we're getting really close to talking about system profound knowledge, but system profound knowledge is one of the elements of how Deming felt you had to be able to understand complex systems, and that meant that like Deming would say that variation is sort of part of natural life. If you thought the number was 42, it's not. It's 41.9998 or it's 42.0005, right? And then if you look at it again, it's some variation between the two, right? And once you understand that, like everything changes. The management approach, the learning, human factors, again, most of this stuff you probably already know, mindset, right? So curiosity, joy and curiosity. So all right. There are three primary tools, and I didn't really understand this. Again, my sort of like how I started thinking about Deming was was the 14 points. And this is great. And it looks like DevOps, and that's going to be cool. And then I had to dig a lot deeper to understand what the heck was he talking about for profound knowledge. And then even when I got that, I still was missing a critical piece that even Deming doesn't do a great job of gluing together these three pieces. You almost have to sort of study Deming like the peeling the onion, like pulling the things off the onion, and eventually at some point you're like, oh my God, yeah, they all have to work together. Um, and so the system profound knowledge does not work without operational definitions, and then the 14 points are sort of the playbook. So that one of the things that I think Deming used this, but I went back to find it, and I know I've used it in the book, but the idea, like the metaphor of a camera lens. So if everything we deal with is a complex system, then we can use the sort of metaphor of a camera lens having, I think I use it back here, like things like aperture, the focus, right, shutter speed, right? Like think about like there are four elements that you would Deming described four elements, so we'll see what they are. But things like using focus to sort of clear the blur, framing, and so this metaphor of a camera lens is a really good way to think about how do you get a perfect picture, right? And speaking of perfect pictures, I tell this actual story in my book about the sailor and the nurse when they announced that World War II was over, right? It was kind of weird, right? He just grabbed some woman and kissed her. Like, but so I kind of question what that was all about. But at the end of the day, like this is one of the most famous pictures probably ever, right? But here's the thing, like, how do you get a perfect picture, right? And like I don't know if the photographer was the greatest photographer ever, but he definitely created one of the most interesting and almost immortal pictures, right? So think about the sort of metaphor of the language, like the complexity of getting, was the focus right? Did he have the blur? Did all those things, the aperture to get this, like that kiss at the right moment, right? Like all those things, or a form of complexity that a lens is used to sort of gauge. Well, so if we think about Deming's journey, Deming's what they call system of profound knowledge, or sometimes referred to as SoPK. It's made up of four elements. One is theory of knowledge. This is your epistemology. So the question is when we're trying to understand complexity or complex systems, or really anything that we're working with, a new change, a new sort of how we're trying to figure out why something broke, or any sort of potential. The first thing we need to be is realize we don't really know anything, and like what's even really fun is when you get into quantum computing, you realize how much we really don't know anything. but but before quantum, right, we still don't know anything. And so the first question is, how do we know what we think? So emphasize think we know. And I think that's a core of knowledge, right? Like as long as we know that like the only way we understand things is we got to constantly question and sort of calibrate or learn, or kind of scientific method. And then if we're using that, then how do we understand what we think we know? And this is Deming's theories of variation, or understanding variation, right? It's never 42. It's 41.9998, or it's 42 points, and it varies, right? It's like if I look at it, this snapshot, it's this number, this one, and what really becomes important is not is it an exact fit in the exact number, is the sort of the he would call it the sigma, the standard deviation across that with it in a range that sort of makes sense. We'll go into that a little bit deeper. And then like I can get all that right. But if I don't understand how people are motivated, they're intrinsic or extrinsic, intrinsic. There's like seven classes of intrinsic motivation, so it's not just binary of intrinsic versus extrinsic, right? Biases, all the cognitive biases, like Kahneman and all those guys, right? Kahneman, like again, I didn't find any direct links of Deming to Kahneman, but like certainly they definitely there's no possibility in this universe that Kahneman didn't read some Deming. Um, and then again, I like at one point I called this the fourth discipline, and I got like torn apart by the Demingites, and so I kind of backed off. But I think because their argument is you use all four of these equally, and I totally agree with that, right? But I do think that what Deming was talking about, appreciation of a system, was basically systems thinking, and it integrates the whole, like all of this together is how you get the perfect picture, or how you sort of figure out complex systems. And so Deming's also famous for this idea of plan, do, study, act. That's basically scientific method. It's what Mike Rother calls kata. You could say it's an OODA loop. Again, I'd accept the debate there because I know it's not the same thing. Or you could say that, Eric Ries in his Lean Startup book, in one of the early editions, he had a whole tribute to Deming, but Build, Measure, Learn from Eric Ries. All right, so I wanted to talk about some stories that I used in the book to try to emphasize system profound knowledge. So you may or may not have heard this story, right? In 2012, it was the second largest high frequency trading sort of black box trader, Night Capital, and on the NYSE and Nasdaq. They did electronic trading. They had an average of 3.3 billion trades each day. They're worth over 25 billion. They lost 440 million in 45 minutes. Now, if I was taking a non-Deming systems approach, I would say it was a missing comma in the list of servers that was supposed to get updated. I get into the much detailed, longer story. I also talk a lot about in the book how I use counterfactuals as a learning opportunity on purpose. Um, so I want to be really clear that like I don't know. A lot of this was not public. People lost jobs. They were out of business. Here's the deal. They lost 440 million in 45 minutes. And that wasn't into capitalization. I mean, they were literally out of business in a day. They got a cease and desist from the SEC. And I've done a fair amount of businesses, and I'm pretty certain the thing that you never want to happen in business is a cease and desist from the SEC. And so I broke it down on like how it would make sense in profound knowledge, right? And so if you read, again, you could argue, and I've had this argument with John Osbar, and I love John Osbar because we'll spend 2 hours on the phone arguing and then sort of virtually hug each other at the end saying it was the best conversation we've ever had. So, there is the argument. And again, I would say these are all counterfactuals because I don't know. But if I take the SEC cease and desist, which is sort of this beautiful, like almost like what you should be doing for DevOps list, there was no their argument was there were no code there was no code review, right? So like literally we weren't applying sort of any type of iterative continuous knowledge or whatever. Variation. I think the most interesting thing is a friend of mine worked at DRW at the time, another high frequency trading company. He said that you could have those situations. So what? Yeah, I got to tell a little bit of story. So what happened was there was a sysadmin that was deploying a new application that had an 8 node cluster, and they left out one of the nodes. The really bad thing was that server had never been updated. It had old code on it. For some ridiculous reason, they decided to use a shared flag. So now all of a sudden, the server that hasn't had the updated code thinks it's to run the old code. The old code is a testing software that actually purposely buys high and sells low, should never run in production, and gets turned on. Now, my friend said, that high frequency traders, they have, these type of things happen where you have runaway trades and all, but there's no possibility for it ever lasting 45 minutes. I say never, like I'm not being a complex systems guy, but a person, but I would say in general, it doesn't happen because there are all sorts of triggers and things. And again, there's a story there that they really didn't understand variation or they weren't sort of tracking heuristics. Psychology, I think this is interesting too. There was some great stories, and I cover this in the book. That is very similar to what happened at Boeing. I know we have some Boeing people on the call, but like the MCAS system, right? Like, in other words, there were people who didn't feel it was appropriate to say we shouldn't be putting this system in production. In fact, the system was rushed. The exchanges had made a change. They created a new API, and the owner of the company, the CEO, decided like within the last 30 days, let's do it. Let's go ahead and do it. And then once they committed to it, then they had to do it, right? And there were people that were sort of like we shouldn't be doing this, but there was sort of this fear, very much like the sort of challenger and Columbia, like I forget which one Diane Vaughn talks about within her normalization of deviance concept, but like there was nobody there that like felt comfortable to say, "Hey, I'm sorry if you fire me, but we're not doing this." And then it was clear if you read the cease and desist, they just was not a mindset of system thinking. I also use in the book another really fun story on the Miracle in the Hudson. And And if it looks like all those people are lining up like they're going to church because this picture was generated by ChatGPT. So I just noticed that. So that's kind of funny. Yeah, hey, we're just having a good old time, who's next, Um, but what I use here is Herbert Simon's bounded rationality, right? Like, and I think this was really sort of interesting, that sort of, and what I was trying to say is this, not necessarily this is Deming, but this is an example of sort of Deming's personal of his appreciation of a system. And here's an example of how Deming would have thought about it possibly. And, so, humans can't process all possible options on intent. So bounded rationality, right? Like it's easy to think that, well, why didn't you do that? In fact, in the movie version of The Miracle on the Hudson, right, they were like, they wanted to yell at him for not landing in New Jersey, right? And then he proved in the movie version, actually, the NTSB was actually much more accommodating in real life. But I like the movie version to tell this story. They were going to fire him. They were getting in trouble. Why'd you sort of like, dump $1 billion plane in the Hudson? And and he proved to them like you can't just go by the flight recorder and say this is how it works because it's not how it works in the real world. They had minutes to decide, and it was all such a craziness going on, right? Like there's like Sully was he had been he'd been flying for like I think a combination of 30, 40 years. In fact, he actually ran a blog on resilience engineering. In fact, the flight that he took from California to Charlotte, no, it's from no, I'm sorry, I don't know. He flew two flights. The first flight he took was he was a passenger. And so I'll ruin it for you in the book, but I talk about this passenger reading Sidney Decker's Drift into Failure. It's like how ironic. He's reading Drift into Failure on the flight it's from Charlotte. That's right. His flight from Charlotte to LaGuardia. He's in the back of the plane reading Drift into Failure. And then from LaGuardia to where he was going is when he has to deal with these disasters. So he understood resilience engineering, system thinking, complexity systems, right? So like all this is like working together. But they had minutes to decide. They lacked he understood that they lacked, oh, I know what he said. He'd been flying for like almost 40 years and he'd never had lost one engine and never heard of anybody losing two engines. Because what happened is on takeoff, they lost two engines. And so he sort of, like what Sully did, which was amazing, was that he matched the reality, the limits of reality of what you do in that situation. In fact, there was an example where, when he calls in, there was a delay between the towers. So when the towers tell him to land in Teterboro, New Jersey, he's like, hey, we got bird strike. Bang, we lost two engines. Bang. And there's this sort of, by the time the flight, the tower gets back to him, he's always one step. He's like, yeah, too late. I'm doing this now. And by the time they tell him to land in Teterboro, first they tell him to go back to LaGuardia, which is like, yeah, that ain't happening. And then they tell him, okay, we're going to prefer you to land in Teterboro. And he's like, yeah, it's too late. I'm landing in the Hudson. And then the coordination in the Hudson was it was really incredibly coordinated, right? And so if I look at break down this of the SoPK, right, appreciation of system, it was an effectively functioning system. The co-pilot, the flight attendants, the tower, the tower wasn't yelling at him, no, go back to Edinburgh, don't lie, like they were all working, in a way a system should work, right? But here's a really funny story, which was the first thing the flight pilots typically do is they'll go to the flight operations manual, right? The aircraft flight manual. And in US Air, in a money-saving effort, decided to take the colored tabs out of all the books to save, I don't know how much they saved in the increment. But so the poor co-pilot is like flipping through now and he can't even find the tabs. Now, there was no procedure for losing two engines on takeoff. But on the knowledge base, again, the story of he was reading Sidney Decker's Drift into Failure on the previous flight, right? Theory of knowledge. Again, he'd been flying for decades, and he'd never even experienced one failure engine is two. Again, so this idea of like practical theory, understanding, basically taking methodical, not losing his cool. And again, this is a psychology principle. He didn't let fear drive things. Now, again, most pilots are pretty good at this in general, right? Like I've been in a couple of flights where we had to do emergency landings and you know what they touch and goes, and it's kind of it's eerie how calm. I've had a pilot one time say, you know, hey, you know, we think we lost an engine. We're just gonna go around and come back. Y'all just calm down. You know, like, yeah, no, that's not the way I behave. Um, this is my favorite all-time greatest, I think, quote when it comes to system thinking is Taguchi. You know, Taguchi loss function. And by the way, in the sort of in Deming's book, in the New Economics, I believe he talks about loss function. It was like a third edition. But like, think about this. This is like quality is the minimum of loss imparted to society. Like, I don't know. I mean, if that doesn't give you chills, I don't know what does. So, so I wanted, we're sort of winding down. Again, I don't think it makes sense. And I know like maybe, hopefully people aren't like, oh God, I wish this guy would shut up. But like, I think if you want to understand Deming's, how he thought about AI, we have to go through these painful sort of definitions. And operational definitions are incredibly important to understand how these fit in system profound knowledge. And so Deming would say an operational, remember this comes from Percy Bridgman, right? The original. But operational definition is a procedure agreed upon translation of a concept into a measurement of some kind. Okay, that seems pretty straightforward. But then he goes on later in the New Economics, he said, there's no true value of any characteristic state or condition that is defined in terms of measurement or observation. Now, wait a minute. What in the heck is this guy saying now? That sounds pretty crazy, right? But if we look at, here's an example. One of his students did this thing. And this really helped me sort of understand like what is he talking about? Why operational definitions are so incredibly important to what we do, right? And so the one of the questions is this, so count the number of horses, elements, and pigs. I'll give you, no, I'm not gonna make you count 'em. Because the first question you're gonna start asking is what do I do with the broken ones? Do I piece them together and count it as one? If I can figure out that it's a head of a pig, is that, but it's only half the cracker? Like the question is, you know, like you got to give me a sort of clarity of like, what are we doing here? How are we measuring this? What is the game, the rules? So a better one is this. I love this is my favorite one, right? So I ask, you know, people in a presentation, count the number of people in the restaurant. Okay. Do I count that woman over there? Is this a mall? Is that a glass there? I mean, is she just walking by the restaurant? Is the woman behind us thinking about coming in or not? Should I count the waiter? It looks like it's open kitchen. Should I count the cooks? And at this point, I kind of yell, why are we counting? That's the first question, right? Like, are we counting because it's it's supply chain and I need to order around of food? Then I'm probably counting the people who are sitting down. If it's a weight distribution or fire code, then I'm probably counting everybody. But the first question really has to be, why are we counting in the first place? What was the point? And so, so as Percy Bridgman says, and this is, you know, I'm not going to read this because this is just hard to read and then it's hard to understand. And I'll just summarize what he says here. Bridgman, so Bridgman was literally trying to calibrate machines that tried to gauge the pressure used to create synthetic diamonds. Okay, right? This is 19th century stuff. And he was very frustrated, right? Because he was always trying to create measurements of things that we didn't have instrumentation to measure, right? And he was incredibly interested by Einstein's basically work on you know distances and measurements and stuff like that. And so he had this sort of epiphany, if you will, that he said the things like there's no meaning apart from a physical operation we perform to measure it. So something like a length. In other words, if you want to measure length, it means you must look at how we measure it. So it's the measurement that is it isn't the sort of the innate nature of that thing. It is the measurement. And so like, for example, length is a good one. Is it the ruler or is it speed of light, right? Because we use length interchangeably. And then we can come up lots of examples there, right? So what he's saying at the end, for that long statement in the previous slide, he's emphasizing that the measurement of a concept is defined by the procedure used to measure it, not by some abstract idea that exists independently. And Deming used this really cool thing, like which is Like, what if our commitment was to quality, which is all sweaters will have 50% cotton. And if that's where we stop, then like, could we have a sweater that's the front part is wool and the back part is polyester? Yeah, that probably didn't work. So what are we measuring by? Is it by weight, by volume? Is it the number of cotton fibers in the matter? So so let's take, all right, so Deming, yeah, so let me see this. So what Deming would say is if I wanted to do this thing for cotton or in general, I have to have elements of an operational definition. Now, Bridgman had his, um, Wheeler probably has the best definitions of these, but I'm going to stick with Deming because it's about Deming. So Deming would say the operation has to include three parts. It has to include a criteria, what's being measured or observed. So the question now is 50% cotton. Great. All right, that's fine. That's the criteria. But now, how are we going to tell? So what's the test? And so maybe this, in the case Deming example, would say maybe we test every 100 sweater using a 1 inch square, and then we test how now we can say is it on average 50% cotton, and then how do you decide whether it meets the standard, which is the decision? Like, why did we measure in the first place? What is the decision? And including everything has variation. That if like every 100 sweater, 1 inch square meets our requirement 50%, then we're probably in the safe zone of saying our sweaters are. Um, but again, if you think about like if we just use terms, let's say go right in. I'm going to skip this really because I know it's really, but so where this boils down is how we use terms in our industry is just horrendous. We say lead time, root cause, zero defects. My favorite all time is one of the Salsa. I think Salsa has the Google sort of I forget what Salsa stands for, but it's one of the DevSecOps type things. A hermetically sealed deployment. Like I'm not really sure how you do that, but hey, service level agreements, best efforts, a microservice, continuous delivery, um, configuration manager, or even our sort of systems thinking and complexity, right? Like we have to be really careful about how what we mean. Like, hey, the root cause was, Joe brought down the system, right? Like, I'm pretty certain everybody on this call realized what a nonsense statement that is. But like you know, I would argue Deming would hate the word root cause. If you go into the Allspa, Dr. Woods, and rest in peace, the brilliant Dr. Cook, um, like those are like you're going to get into a fight. You're going to get a Donnybrook will break. If you go to LFI and start talking about road cars, I'm pretty sure you're gonna not have a fun time, right? So again, like if I take the door stuff, and here's the thing, I'm pretty rough on the door. I'm rough on all DX, to be honest with you. So the DX, like, there's some of them that really like me, but they like me because they put up with me. But I think that developer experience or developer productivity metrics are missing the point. But that's another whole presentation. Um, but I do say, and Dora was great when it first came out because we at least started thinking about more of us, as Nicole Horsham would say, we're sciencing the shit out of this. We're sciencing the shit out of DevOps. And she was right. She was a scientist. She did psychometric survey. I mean, she was brilliant. But today, 2025, without operational definitions, these things are best case useless. Um, sort of a more dangerous case is harming. Like what do we mean by time, right? Like go back to sort of length with, and so like if I take the question of Deming's criteria test and decision, let's take lead time. Why are we asking? Is there a good or bad standard? I mean, like again, if you take the general public survey at Dora, like there's sort of what low, medium, good, and supercalifragilistic performance, right? Like, what does that even mean? And like because you can do 8 billion deploys every nanosecond, does that make you better than somebody who does 5 deploys every hour? Of course not, right? Um, So the question then is, what is the criteria and of like why are we looking at lead time in general? Now, again, I think people have made arguments that it can give you a sense of like progression or improvement, and I have no problem with that. But that's not how it's dogmatically implemented. I mean, people literally try to put classifications, and I've seen green, yellow, red mappings where you guys are not doing enough deploys every day. You got to get your deploys up, or you got to get your lead time down. And by the way, lead time is an average. I think any metric that is a mean, I think you should just leave the building. And the test. What are you measuring? Is it delivery? Is it deployment? Continuous delivery until deployment have clear, again, in the sort of overloaded term, operational definition, but like if we're taking sort of what a general explanation between the difference was, they're different. And so which one are we using? Are we on the branch, the master branch? Is it on a pull request? Is it on a commit? What about dark launch, feature flag meeting? When does this average that we're actually judging people on? So I get a little excited. Sorry. Actually start and end, right? And then the question is, what was the point of it? It's changed behavior. That's pretty squishy. A couple more things before we get into AI. Maybe Barbara, the AI is a good time to take a break. When I get to the AI part, we could take a break. I
Okay,
know.
great. Yeah. I
Yeah.
want to just get in some questions. We have one in the chat, and I'm
All
sure
right,
there are some
I'll
others.
sort of breeze through this real quick, and then I'll hold off on the 14 points, and then we can save those for later because I need some really good analogies of these sort of things in practice that I used in the third of my book. But this is an important part too. So Deming coined this analytical statistics, right? And again, I won't spend a whole lot of time on it, but it's pretty brilliant. And to me, I'm just always befuddled of why we don't use this more often in our industry. But the idea is, and it can be mode or mean or you literally take time series data of things that are happening. And Schuart used this originally to fix like they in Schuart's factory they're building telephones in the 1920s, right? And they're building telephone factories, and it's like this is the biggest thing going on. This is bigger than AI today. It's the telephones are like holy mackerel. I can talk to my aunt in California, and I hadn't been able to talk to her in a year since she left, right? And I'm from New York, right? And so he figured out, like, why do we have 5,000 testers in a 40,000 person plant, and our quality still stinks? So he realized you could do this idea of sort of time series and on errors, and you could look by just using principles. And he was a physicist too. And then you take Bridgman's work that influenced him, and you could look at, and actually some of the epistemology played into from Paris is what you can do is you can sort of use this idea of what he called, and this is where Six Sigma comes from, by the way, is from your average, you're Three Sigma above and Three Sigma below. And in general, and this can change and you can sort of modify, is what we'd say is everything that happens within the Six Sigma is what they call common cause. It is in general the voice of the process. And by the way, you shouldn't see straight lines because variation is a part of the physical world. And so what you want to see is a smooth variation. And when you see patterns in here, so the ones that are outside the Six Sigma, Three Sigma, are clear, what he calls special cause. And some of those are like, hey, there was a nefarious actor that broke the system, or a lightning bolt took out the power grid, right? Like those kind of things. And like those are sort of actually easier to understand. It's either, sort of like things you can't really deal with or things that you could deal with directly. It's the sort of like, okay, what's happening normally during the time and what does normal look like? And that's really the art of this. And, I'm not doing it justice here, but I would say read, what's his face? Wheeler's book. The Understanding Variation is probably the best book on this. But here's the point is, and I got to do my presentation would be full of what Jay Bloom shout outs, but Jay helped me really understand this. Was pretty good because I didn't really understand until Jabe explained it in a presentation one time about like enumeration asks how, analytical statistics shows why. So in other words, I don't get to really see the trends on that bottom right slide, right? There's something going on there. And like the fact that they're in a row right there, like Deming was saying, we should have just clear variation. So like up until the 18th observation or 17th observation, it seems like we're getting a reasonably consistent pattern of variation. Maybe that is the process. Most interesting, famous example of this is Deming's red bead game. But then all of a sudden, it just starts increasing. So maybe let's say this is the temperature of a server room, right? And now all of a sudden the temperature is going straight up and still within the upper control limit, but by then we see the pattern and maybe we can address it. You know, the argument is you don't really see that in enumerated. And we tend to use enumerated way more than we use what Deming would call analytical statistics. All right, so the 14 points are, I think we'll come back to this. There are, if we have time at the end and people still want to hear me talk, that'd be great. But I use some modern, this is all in my book, modern day examples of
Check
different
that
points. Oh, let
and
me do
see
this
if I
one really
missed
quick.
it.
What? I'm sorry. Sorry. Oh, I just do one. I'll do one, and then this is the one I have to do, right? So Deming had a 14 point, never stop improving, and so I think it was actually Richard Cook's quote. But incidents are unplanned investments. Their cost already been incurred. Your always challenges to get ROI. To me, that is like Deming's number 5 point. All right, so I'm going to stop right here, and then we'll get to talk about AI. Sound good?
Okay. Yeah, that sounds great. I know Dave had a question in the chat. Dave, if you'd like to unmute yourself and ask your question, and then we'll see who else has a question as we go on, okay? Or Dave, are you just too shy to talk?
I wanted to make sure it was the right day. Um, yeah, when you talked about using all four equally, and the first thing that popped into my head is that you may use them all four equally over a broader period of time, but maybe there's a danger of trying to do all four equally at the same time.
Yeah, I mean, so this is again, this is the sort of like when you're talking to an old Deming crowd, you just got to be a little careful. But I like to think of it as doing it there's nobody's ever prescribed an order. I think there is an order. I think the first thing you do, I think the point is, so I might have said that wrong, but like, and what I didn't say is what I do say in the book, which is I think the first element is how do we know what we think we know? Right. So I use that first as the sort of like questioning scientific method. It's, it was also be described as, sort of Deming's PDSA. By the way, Deming never said PDCA. He hated it. So when people sort of quote Deming as he's the founder of PDCA, he didn't like C because C implied, I read an article about that.
Yeah.
All right. So the first principle, and then sort of the understanding is, like how do we understand, like, and that's variation, right? Like in other words, there's not one set answer. And then before we get too far down the road, let's make sure
Thanks
that
for calling H&R Block, located at 5322.
You're welcome. What you call it, the psychology is okay. Now I can't like not apply this, right? Like in other words, one of the like I was struggling trying to understand system profound knowledge when I first sort of like the 14 points. Great, this is so I can put this in my DevOps presentation. This is gonna be great. But then I'm like, okay, but the real meat of what he was doing, and it's kind of funny because like it's not until like
Your
91,
message after the tone. When
91 and
done, hang
92,
up or press the pound key.
91 and 92.
Hi, Regina. It's Kinsey.
Okay. 91 or 92 is where he literally sort of culminates this thing of his 75 years, and it's called System Profound Knowledge. And so the idea then, so as I was trying to figure out, like, can I get an example? And one of the most interesting ones were like in healthcare. And healthcare was really big on Deming. And they talked about hand washing. So you could use all the data and epistemology and science, and you could show control charts and run charts and all that stuff. But if somebody just didn't fundamentally believe that hand washing killed germs, you really were not going to get anywhere. And so I think that's part of Deming's brilliance is that you have to apply that. You have to sort of try to figure out, are there any sort of cognitive biases? What is the sort of motivation? And then at the end, am I sort of circling the wagons with a systems approach? Like, am I working my way out? And so you're right. It isn't So if I said that earlier and I didn't say it right, which is try to apply all four equally. I think there's more of a sort of method in that you should apply all of them in trying to uncouple what he would say is a complex system. Does that make
Yeah.
sense? Yeah.
Yeah, it does. And which one you apply may be context dependent at
Yeah.
that point in
I,
time.
I'm not sure, but I do think you would always start off with the theory of that one.
No, that makes sense. Yeah,
Yeah.
that makes sense.
Yeah.
Okay, thanks.
Sure. I was afraid you're going to give me a hard one.
Give him time. He'll come up with something.
Don't
Yeah.
encourage, in other words, don't encourage him. Yeah.
Yeah,
okay.
you don't want to throw down that particular gauntlet here.
All right.
I got
Yeah.
another one, but I'll wait.
Okay.
All right.
Well, are there any other questions? I mean, Kinsey, did you have a question or did you just accidentally unmute yourself? Okay, I guess it was an accidental unmute. Dave, why don't you go and ask your second question while I check the chat?
Sure. Yeah, it's along the lines of these things can be theoretical, or you talk about Deming and Goldratt, and people go, well, what am I supposed to do? And yet it seems to, at least from my experience, some people can read that stuff and come up with, here's a list of things I need to do. And other people read it and they go, this is theory. I have no idea.
Yeah.
And it's just kind of interesting to me. Maybe it's the psychology part of how some people can read something and go, oh, yeah, some practical things I could do. When we presented Kinevin, it was like there are people go, this is really practical. And then there are other people went, oh, this is just theory. So it's just kind of fascinating, the psychology of people and how some can adapt things a lot easier than others.
Yeah, and I think there's a lot to that, right? And like we could go down a real rabbit hole here, but I do think how people, think about learning. I mean, there's, how many times like I've been in and out of like I've worked on large software projects multiple times in my career. Spent 2 years developing code, just like 10 hours a day just writing code, right? And then how many times you'd have somebody like a junior programmer come to you and there was again, it's not that the world is simple, that there are two types of people, but there'd be the type of person that would come in and literally ask you a question, and then you kind of at some point you knew you had to answer the question. You tried first like, hey, I think you should go look at the principles operation book and do this, but you realized this was not going to work, and then if you just didn't want to be a jerk, which I don't like to be a jerk, there were too many jerks I've worked for in my life, were like, and you just sort of play along, like, hey, I'm a little busy right now, and then you had the other person that was like incredible. Like all I had to say is that answer is in the principal operations guide. And like, they're gone. They answer the question. Next time they come back, they're like, thanks for that. So there are the people that sort of like they need answers. Again, this is definitely a rabbit hole in me. I used to write, courseware for IBM back when they used to do Tivoli. I used to, a whole part of my career, scars on my leg from doing Tivoli work from IBM. But I used to write the courseware, and like the curriculum management would hate my labs because my lab, I hate the labs that are like, lab 1A, put a comma before this, then do this. Make sure you put a semicolon. Yeah, like in other words, or hey, I just taught you how to do this. Here's what I want you to do. Right. And a lot of students would just like, pound their fist or like, hey, you don't, I had a guy who used to write Linux, or not Linux, Unix books on configuration and was mad because I put a command line that had somebody sort of uppercase the first character of the command and was complaining that it wouldn't work. Like, dude, come on, man. You didn't realize that was a typo. Anyway, yeah, I mean, so yeah, there's an interesting way, but then, here's the thing, right, Dave? I think we have to be effective with both, right?
Oh, yeah.
Yeah, and that's a hard lesson to learn, right? Because it's easy to be like, I want to be near these people, but like, in the systems view of how I'm going to get an organization to work correctly, I got to be accommodating for everybody.
Yeah, they're both there.
Mm-hmm.
And I think you're right. It's a continuum. It's not they're all like this or they're all like
Yeah,
that.
yeah.
Yeah,
That's a
but
great question.
yeah, you have to go. How do you deal best with what you got?
That's right. That's right.
Yes. Well, and that was, I mean, to circle back to something that I was thinking, having read your book and listened to the first half of the talk, is that you do a really good job in the book of situating Deming in his historical context. Because I think it's really important sometimes to look at the external forces that shape these fake. I mean, Deming was born in 1900, World War I, Spanish influenza, Great Depression, World War II, post-war Japan, Vietnam. And, you look at the sort of, large scale historical context that sort of shaped a lot of these thinkers. And it gives you an insight into what their approach and what their grounding in complexity really is.
Yeah, no, I mean it's clear. So again, it's like, I think probably, one of the funny things that comes up a lot in AI is, especially in sort of educate. I've been doing a lot more volunteering on a friend of mine's, his daughter has built a really interesting a school for neurodiverse children, and it's just been phenomenally successful, and so I go in there and try to mentor, and the complaint that you get from a lot about AI and sort of like K-12 education is it doesn't, it might eliminate critical thinking. I'm like, yeah, I don't think we're really good at critical thinking, even in college level. How many people get an MBA and like they're not critical thinkers? Like, so, but I mean, critical thinking is, not to get too personal, but like that was, one of the most important things I had to do to raise my kids. Two boys, and like I didn't want to make sure that when they left the nest, they had that one down. So and I don't know, I don't know how do we get people, but Deming was a critical thinker, right? Like, and even to his demise, like his grandson, you read this probably, Barbara, in my book, right? His grandson had asked him a question, and he just answered like 217. And like the grandson was like, huh. He scratched his head, and about, 2 hours later, he realized, oh, it's page 217 of Out of the Crisis. Yeah. So Deming was very curt. Like, in other words, let's move on, let's move fast. And we're all, like everybody I'm talking to better be a critical thinker, or else like, you're gonna get left behind. And there's a lot of complaints about him in that regard. Um, but um, but yeah, I think it just comes down to like we really need to do a better job in our sort of the way we train children, the way we stop worrying about AI and worry more about like critical thinking and system thinking, and even in a large corporation. I've done advisement for smaller banks. When I was at Red Hat, there was a couple of I came reasonably close with a couple of CIOs in Asia, the Pac Rim, and like we'd have these great talks, and I'd say, I think you're ready for this remedy, but like, which I would say to small, like if I was going to do something, I would create a systemic. I would literally challenge everybody in my organization to understand system thinking. Or people disagree on this. I'd make everybody on the planet read Donella Meadows' Thinking in Systems. So, and I think we'd be a little better than what we are in general. But that's me.
Okay.
I'm
Well,
crazy.
do we have any other questions? Please raise your hand. I've tried reading through the chat. There's too many things.
Oh, that must be interesting. I have to get back
It
in.
makes me tired.
Yeah.
Yeah, we have a lot of comments on books about measurement and things like that. And yeah, if we're going to recommend books on measurement, I have a book called The Making of Measurement and the Promise of Sameness by a historian named Emanuele Lulli, and it's about the sort of creation of measurement standards in the medieval period.
Oh, well. Well, my
So,
Deming. Oh, sorry, Barbara.
go, no, go ahead, John, please.
No, you mean my Deming book? I do a fair amount because Stewart. If you read Stewart's original book, right, he talks about the history of measurement. And he talks about, really tools, but basic tools and measurement, right? So he does a great. So I tried to recreate that in the Deming book, like when we go back to, before we had fitted parts, right? Like we had, sort of there was sort of measurement of stones, like carving stones, and then there was sort of, and we went like a ridiculous amount of time before we got to the Industrial Revolution, right, where we had interchangeable parts, and interchangeable parts created this whole new question of, go, no go, right? In other words, like now the fact that it's not artesian, that we don't put a rifle together by just putting, some sort of clock, watchmaker putting it together. It literally is now we're going to manufacture multiple of them. So now what we're going to find is we can't just say it's this many centimeters or millimeters, right? We got to basically the whole concept started getting creative, like go no go, right? So no go really accepted the reality that there's variation. Not every part's going to get it exactly the same. So then you get into sort of and then, which leads to where he got to statistical process control is everything has variation, right? So I thought that was Schuett's work, or, I think I did a pretty good job at least explaining that part. And what's really interesting, and I don't know, like I run the risk of, I'm a very rabbit hole kind of person, but like as I'm going back and refreshing my Percy Bridgman stuff, and I've been literally just gonzo for the last 6 months on quantum. When you talk about measurement and quantum, now you're talking about a whole nother ballgame. But I think I realized when I was preparing this presentation, I started looking back at some of Bridgman's stuff. Again, him being not a quantum, pre-quantum mechanics, but like there's just an interesting conversation about his view about a measurement is really what describes what something is. It's not what something is. And that's very quantum. So
Yeah. And there's always the question of what are we measuring for, right?
But that's
the original point of measurement was based in many ways in the idea of fairness. That, if I'm getting a measure of grain from you, and I'm getting a measure of grain from Dave, they should be roughly the same.
Yeah, that's right. That's right.
However roughly we want to make that. But yeah, that is a rabbit hole. So if there's no more questions, and I don't see any in the chat, and I don't see any hands up, let's go for Rebels of Reason.
Brilliant. Okay, so like I found in my Deming book, I've done a fair amount of little books with Gene, and I did the Devil's Handbook, but when I decided to do the Deming book, I love this. I love like historical technology, right? And storytelling is the core. Like I want to tell this. I tell you the story system, profound knowledge. I give you lots of examples, but at the end of the day, I want to have a human. Like I want to have a story that has incredible humanity to it, right? And as I was thinking about in that next book, I started like, okay, let me look at what's going on with this AI thing over the last 100 years, and I thought, oh my God, this is another like fabulous ability to tell technology through humanity, but like like solve that for double purpose. Like again, another Michael Lewis like story. So I researched about now the interesting thing about AI is I did AI in the 80s and the 90s, and so I did sort of early incarnations of not neural networks, but and then I sort of shifted my day job. So all the time I'm writing this book, I sort of started taking more clients on, helping them scale large scale deployment. So in other words, how do you change 5,000 Java developers into AI native developers, right? Like, that type of, and I'm not saying like we hit buttons to do it, but like the how is the interesting and hard part. Anyway, so I started thinking about this book and then, I'll just quickly, it's just the human stories were just fabulous. And the idea was generally, I wanted to be able to tell a narrative. I usually have two target readers. I usually have my mother-in-law, who's a high IQ reader, but she's not a technical reader. She doesn't read technical books, but she loves good stories. Like she loved Moneyball, right? And then I want a subject matter expert. So I had a subject matter expert in line for this one. I had one for Deming. It was Ben Rockwood, actually. And I want to make sure I read a book, and when it's all said and done, they both enjoy it. And they got value out of it in two different ways. But I like the sort of the storytelling as sort of, and so as Ada Lovelace is just a fast. I mean, I do a little bit of Boole and Babbage because before you get to neural networks, you have to have. I mean, the sort of the first neural network by Walter Pitts and William McCullough. We'll talk about that in a minute, but it's sort of based on the calculus using Boolean logic, right? But Ada Lovelace is, she's fascinating. And then Alan Turing, of course, you can't not talk about. Walter Pitts if we have time, I have like bonus material. Walter Pitts, and like if this doesn't entice you to read this book, he is a modern day Goodwill Hunting. I mean, I'll just leave it at that. It's eerie how smart this guy was. He never had a formal education. I mean, like, and he's one of the founders of neural network. Claude Shannon, who was big in AI, and that we start the book is like that you might be walking in the Bell Labs building in Manhattan and coming around the corner, and next thing you see a guy on a tricycle or unicycle, sorry, unicycle juggling. Claude Shannon. I mean, John McCarthy, Grace Hopper. Like I read 25 books on the history of AI. Not one of them talked about Grace Hopper being important in the history of AI. Without the compiler. So compiler was like how you start talking about turning bits and bytes into natural language, right? Jan LeCun, Janet Baker. How many of you know that we don't probably have Siri without Janet Baker? So I have a whole chapter on Siri, and it starts with Janet Baker and her husband. Jeffrey Hinton, you probably heard of. Dennis Hassabas. Again, that story is just amazing. At 4 years old, he beats his dad in chess. At like 11 or 12, he's a chess master. At about 13 or 14, he's sitting in a chess tournament, realizing how much wasted brain power, and we could be curing cancer. And what did he do last year? He won the Nobel Prize, right? For Fei Li. Fei Li, you don't have ChatGPT in 2022, I argue, without Fei Li. Fei Li is the linchpin between ImageNet and AlexNet. Like, again, I explain all that. That's not the point of this presentation. I just wanted, and then Joyce Boulami is an incredibly interesting woman who talks about AI ethics and the what did she call it? The gaze, the AI gaze. How AI basically the trained models on visuals are like high percentage white males. So the questions you get, especially when you talk about surveillance and stuff like that, it's really interesting. All right, so let me tell you the story of how we sort of close this narrative or this presentation. So during my Deming book, all my stuff by Herbert Simon, John Allsbar, and Dr. Woods had sent me the flight recorder stuff for the Miracle on the Hudson. And that was very helpful. And I had told John earlier I was going to do Boundary Rationale with Herbert Simon and all that, so I don't know. I was about 70% done with the Rebels of Reason book, and periodically me and John just hop on a call and we sort of argue for 2 hours about something, and hug each other when we're done, talk about how great that conversation was. So I told him, oh, by the way, I'm writing a book about the history of AI. And his response was, of course you are. Like, I'm a cliche. I accept that, right? And I said, well, but the reason I mentioned that is Herbert Simon is a big part of history of AI. And I guess I didn't realize it until I did my research. He goes, oh, Dr. Woods is going to want to talk to you. I'm like, okay, sounds good to me. Like, yeah, one of the most brilliant resilience engineer guys on the planet wants to talk to me. Hey, let's make this happen. So we get on a call, and I think the first thing he wanted to do was he wanted to make sure I wasn't going to write a rah ChatGPTs. I mean, he should have known better, but like ChatGPT's greatest, and let me tell you how you're going to be made millions with ChatGPT. And it was pretty quick that he realized that wasn't the case. And but then the other thing was he studied under Herbert Simon at CMU, right? And so he had some really strong opinions about Herbert Simon. So we get on a call, and then the first thing he starts talking about is, and Dr. Woods, these guys are so brilliant is that they can't and it was insane. I spent like 2 1.5 hour sessions with him, and then I did a podcast with him. And what he wanted to make clear is that, that sort of AI has some Achilles heels, and I'm not disagreeing with that. And the Achilles heel was, and sort of he would never agree that I summarized it this way, even though I think I'm summarizing his argument correctly. I'm pretty sure he would never accept this summarization, is if we think about expert systems. So really there's 2 types of AI. Again, trying to keep things simple, even though there's never 2 types of anything. There's basically what they call symbolic AI and sub-symbolic AI, or sometimes referred to as expert systems or neural networks, right? And so you could argue, and I have argued, that in the simplest form, expert systems, or what's called symbolic AI, is based on deductive logic, right? if you want to take another leap and say that neural networks or subsymbolic is worst, based on inductive reasoning, I'll stand by that. So I'd love to get knocked off the pedestal, but that's fine. The point that Dr. Woods made, and I was at the same time this is happening, I'm reading a book called The Myth of AI by a guy named Eric Larson, who's another brilliant guy. And both of their arguments go back to, anybody want to guess? Guess? Remember, I gave you a hint earlier. I know everybody's on mute, so I'll just assume somebody guessed right. Pierce. Because Pierce not only was the founder of pragmatism, he was considered the father of abductor reasoning. And so the argument, in its simplest sense, that Larson and Woods made, and I've had a podcast with Larson too, and I've had a podcast with Jabe. In fact, Jabe is the one who actually introduced me when I was writing the Deming book about the concept of most people ask, like, what's abductive reasoning? Never heard of that, right? In case you're saying that right now, I'll describe it as like, if you remember the Columbo character, right? Like he sort of has this combination of instinct, heuristics, history, but sort of some deduction in that, like he can figure out who might be the murderer. One, he's seen this movie so many times before, but two, he's got some like innate instinct of being right at this thing because that's why he's a great detective. But also there was mud on the one shoe and they knew that the murderer had to track through the field, right? Like it's this thing that and so the argument that Dr. Woods and Eric Larson make is that that's what's missing in modern AI. In other words, and I've written an article about this, the model only knows what the model knows, right? And that's fine, right? And so along those conversation, Dr. Woods would challenge me. Each session, he'd basically, give me a bunch of reading material, and I'd come back, and we'd have these great conversations. And like I said, I was finishing Eric Larson's book, and I had a good talk with Jay. All around the same time, I'm having, the real trick to life, y'all, is find really smart friends and just try to hang out with them. But yeah, I was having these conversations with Dr. Woods, Eric Larson, and Jay Bloom at the time about this subject. And Dr. Woods asked me if I would make sure I added something in my book about this idea of, just where AI ain't all that. And there was a lot more to it. He said that, sort of, anyway, the podcast would give the more details of all the stuff that, he was arguing. And I was like, well, if a guy this brilliant is asking me for a favor, like, I'm going to do it. So I struggled really hard to figure out, like, how do I tell a story? So I decided it was going to be an epilogue. That's fine. So that actually was more like waiting till last night to do my homework because I literally knew I didn't have to worry about it. And I could write the book, which basically is just a telling story of AI. I try not to be like rah-rah. I mean, I told it as it is, it's almost like a journalist. And, but I got to the hard part of like, oh, how do I do this? And then at the same time, so I wrote a blog article, or a newsletter article, which is basically almost exactly what is the epilogue of the book. And I called it The Philosophy of AI. And that's because there's another smart guy that I get to hang out here is Laksh Rakhavan. And we've done some podcasts together. And so he challenged me. So I was telling him about this idea, like and all this abductive reasoning and he's like he's a big cybernetics guy, systems thinking, complexity, all that stuff. You should definitely get him on the show. And so he challenged me to like, hey, next time we talk, I want you to sort of come up with an idea that would sort of be around this idea of what is the epistemology of AI, right? What is what is a historical perspective? Let's see. So I started working on that. I went down a rabbit hole. Almost wrote another book. It's still out there with like 70 pages. But there's a historical argument, and that this goes back to something you said, Barbara, right? Like I think it's important, and I think it's a good argument for my book. Is even if you don't read the epilogue, which is like you can't just wake up in 2025 and say AI started in 2022 with ChatGPT, right? Like. I think it's important to understand. And you can see it in the history. Like people have discoveries, and right now we're working on sort of the generalized pre-trained transformers, right? The transformer architecture. Almost everybody who is really knowledgeable, way more knowledgeable than I am, will tell you that's not going to last, right? And so this is where history becomes really important. Even DeepMind came up with something called alpha geometry, which actually fuses, and you're starting to hear more about this, about symbolic or neural symbolic networks or whatever, where they're using neural networks, they're using symbolic and subsymbolic. And if actually Google's article on this, when they introduced alpha geometry, which is very much based on Kahneman's thinking one and system two thinking, right? In other words, you need sort of both. So my meta point is that history is a very important tool. So it's not over right now. It's not like GPT, we're done, like no more to learn, right? No. There'll be something else will happen, and we're going to have to understand the history. So there's definitely a historical argument. There's certainly an epistemological logic, right? Is there a robust theory? Are we even trying to attempt to have robust theories or theory of knowledge around AI? And I think, again, this is where Deming would be like, hey, come on, get out of the way. Let's find out what's going on. He'd be really interested in these two. The ethical argument is incredibly important. But it's a more sort of like, it's a stretched, and there's some really interesting discussions there. It's not because I don't care about humanity. It's just that I don't think I am equipped to focus on that third perspective. And so Locke said to me, and I think this was a great quote, and I put it in the book, which is, to study science, you have to understand the philosophy of science. To study AI, you have to understand the philosophy of AI. In other words, we're missing a discussion around what we should be calling. I'm not saying I have the answers here. I'm basically telling you, here's what I think Deming would be asking, and I think we should be asking. Are we having a sort of a serious conversation about the philosophy? So I'm still struggling at this point to like, how do I still do this in an epilogue that like doesn't sound totally counter to everything I said in the book and makes the point and accomplishes what Dr. Wood's favor he asked me. So as I started building this, what I started thinking about is, one of my sort of co-authors and consultants that I work with on most of my books he came out with this idea that we've been on a quest to build a machine that thinks like humans. It never occurred to us that we might build a machine that thinks differently than we do. Right. So that, to me, that now I had my okay, I think I can write an epilogue now. Because this is the thing. Because one of the things that annoys the heck out of me is how much time we waste in deciding how close we are to artificial general intelligence. It's just a stupid question. It's a waste of time. And I think the next couple of slides in my epilogue tries to make that point. So how do I make that point? Again, I don't think anybody's not on mute. So anybody recognize this? I was trying to get a picture of the movie that this is from. And boy, ChatGPT just wouldn't let me generate it. So I had to just come up with like a weird description. So this is the movie Arrival. And like Arrival is the perfect metaphor. So just to do a recap, if you haven't seen the movie Arrival. It's Dr. Louise Banks, a linguistic professor, probably in the movies. There's a book based on this too, but she's probably the best in the world, right? And the military comes to her, and they want her. So basically, these like heptapods, I think 11 of them, land, and everybody's like, oh my God, there's one in Russia, there's one in China, there's a couple in the Midwest, and what are these guys here for? And the only words they can interpret is this word weapon. And so she's asked. So here's the story. So the general comes into her, military general, and says, "Hey, we need you to help us figure out how to talk to these." And everybody's scared to death because there's 11 of them. Nobody can talk to them, and all they heard is the word weapon, right? Which doesn't sound good. And so they go to talk to her, and they ask her if she'd be involved and help them try to figure out how to communicate. And she says, "Well, I'm going to have to go in the ship and talk to them." And they're like, "Not an option. No way." And so the general starts leaving, and she says, "Where are you going next? To such and such?" So she knows who the second best linguistic is. And he says, "Maybe." So anyway, he leaves. The next day, a helicopter lands on her lawn, and they come pick her up. And she asks the general, she says, "Oh, I'm sorry, I'm leaving out a quick part." One of the things that she asks, she says, "Oh, if you're going to go to such and such, ask him what the Swahili definition of the word war is." And so he comes back next day, And she says, what was his answer? And I mean, like, I had to replay it like 10 times to hear this dialogue. It's almost, you can't even hear it in the movie. And he says, his answer was, something like conflict or sort of, and it turns out it's two cows or more cows. In other words, and so I'll make the point of where this is going is that um, her fear was that the only way to communicate with them is they had to be in the ship to communicate. And second was if you got the wrong person, everybody would focus on the sort of military interpretation of what humans think words mean, right? And so Louise realized weapon means tool. This is what, to recap the story, she figures out how to sort of communicate with them, and weapon means tool to the heptapods and changes human perception. And it really was them warning us to preventing a war in the future, right? And so the sort of metaphor that I wound up using is that Arrival is a metaphor for humanity's approach to artificial intelligence. We're making a mistake when we try to compare what I would call alien intelligence. Other people come up with better terms who have read my blog, right? Alien intelligence. It's an intelligence. Like we can argue this all day long, but like to say that it isn't a form of intelligence, I think is wrong. It's just not human intelligence. I mean, there's definitely, the things that are happening, and it's pattern matching, it's probability, it's statistic. I mean, it's cosine similarity, basically at the core of it. But at the end of the day, I don't know what's going on in my brain. My brain is cosine similarities in a chemical, biological way. I don't know. All I know is I don't think that to sort of say it's not intelligent. It is not human intelligence. So then discussions about AGI or ASI are a waste of time. So she learns how to communicate by abandoning human-centric assumptions. So I think there's an argument to be made from an epistemological view, and I don't have the answers. I'm just saying I'd like to see more people be having this discussion in that, and I think this is where Deming would be setting right now, is is let's just assume it's an intelligent and it's not a human intelligence, and then we have to do what Louise Banks does or Dr. Banks does in like literally try to abandoning our human-centric assumptions about what AI behaves and what does. And I'll give you an example. We waste a ridiculous amount of time comparing it to benchmarks. Oh, can it, my argument was if Dr. Banks would have went in there and said, okay, Hepatod, can you ride a bicycle? You can't ride a bicycle. Hey, Hepatod, try this calculus formula. I didn't get it right. Like they would have totally missed the point, right? Um, and then, the key takeaway is that I was trying to make in this, epilogue is to understand AI, we must stop interpreting through human frameworks. And I think we're wasting, Ethan Mollick wrote a great book about AI. I think my book's better. I'm just going to be flat out, right? I'm not an egotistic person. I think my book's better. Rebels Reason is a better book. But he spends so much time every time a new model comes out trying to figure out whether it makes a picture better than the picture the last model made, or can it answer this math question that didn't answer it last time. And I'm not. He does put out some good research, but like we're killing trees. I mean, we're killing trees anyway, but like we're killing trees if we're just trying to figure out can it ride a bicycle better than us. And so AI is an alien intelligence. AI does not think like it represents an alien epistemology. Humans err by judging AI against human measures like the Turing test, the benchmark, emotional reasoning. Uh, Dr. Banks' approach was very scientific. I think, like we could say that she used a system of profound knowledge if we wanted to go take a leap there. She would ask the questions, how do I know? Do I just assume that weapon means they want to blow us up? Or just assume I don't really know what they think weapon means, so let me try to figure that out. And so if I'm going to put, and this is what I do at the end of the epilogue, is I want to put a framework, sort of a Deming framework using profound knowledge. Then I would say that, that sort of Deming would say, if we're thinking about AI, use deductive reasoning, making plausible guesses, and refining understanding through evidence. Like I can, you've all done this. I'm not nobody to teach you don't need me to tell you how to use ChatGPT, but if I don't like the answer from any of the models, I challenge the model. And how many times have you all seen where it says, "Oh, I'm sorry, you're right, I haven't." I'm gonna tell a little. I love telling stories. I can't help it. A good friend of mine just retired. We grew up together. He was in IT, but he never really loved IT a whole lot. But his goal in retirement now is to prove that Shakespeare didn't write all the Shakespeare works, right? Like, so it's a crazy set of like people that apparently, and they may be right. I don't know, but like that's what he does. He goes around the world and goes to all these conferences. And so one night we're talking. It's about 2 years ago, a year and a half. He's like, "I hate AI," and I'm like, "Why?" He goes, "Well, because it dismisses all the theories that we have about the." And I said, "Oh, let's go on ChatGPT and check it out." And sure enough, we asked, did such and such right? It said basically it said no, it didn't. And then I said, "Well, hold on, no, we're not done." I said, "Let's do this. Let's say, hey, ChatGPT, let's assume he did write it. What are the arguments for it?" And then he came out with a whole bunch of really good arguments. And he's like, "Oh, wow, look, those are our arguments." I'm like, "Yeah, okay." And then, but one of like it was 10 arguments, and like the ninth argument was Occam's razor. So this is like this is what I knew. Like you can treat it like a human, but don't think it's a human, right? In other words, I said to it, I said, "Really?" I actually responded with like, "Really? You're using Occam's razor as an argument?" And it apologized to me. So again, I think there's a lot of power in not anthropomorphizing it. I hate that word mainly because I can never say it right. Um, but theory of variation, right? Like evaluations. Like if you haven't sort of learned about evaluations, it's a form of observability, particularly evaluations. It is critical if you're going to be in high consequence environments where you're going to use AI. Because to say you're not going to use AI in high consequence environments, yeah, that's like Austin Airport saying they weren't going to let Uber pick up people there. That didn't last long, right? In other words, it's going to happen. Sorry, folks. Uh, so the question then is like, how do I deal with and evaluations is software that basically uses AI to sort of calibrate hallucinations, correctness, bias, and all that stuff, right? So and understanding that, like again, I could spend a whole lot of time how I think the new pipeline is going to have to calibrate the evaluation data of correctness, bias, hallucination, and that's going to be your new baseline for things like what I would call test-driven development for AI, right? And I've done whole presentations on that. Psychology, right? Embrace the neuro. Oh, that's another thing. Neurodiverse people that you're finding more and more that to train models, they want to recruit neurodiverse individuals. And then system thinking, right? The society and sort of interconnected influences across technology. We need to constantly. So the argument that the model doesn't know only knows what it doesn't. The model only knows what the model knows is the idea that like you always have to understand that there is sort of a boundary. It can make a lot of inferences to create really intelligence. Again, I'll argue it is intelligence, it's just not human intelligence. But at the end of the day, the model is bound to what's in the model. And so, I think a new philosophy of AI isn't a super intelligent, but it is another intelligence. I think to collaborate, we must adopt Deming's outside view and question human-centered thinking, appreciate this alien intelligence in the forms that work for us, embrace nonlinear pattern-based reasoning, encourage cross-disciplinary collaboration, um, the and rather than force AI into a human mold, imagine what might happen if we learn its language instead, kind of like what Dr. Banks did. That's the end of the thing. I told you a little bit about the Walter Pitts, but it's all up to you if you want to hear the Walter Pitts story. But if you don't, that's some of my stuff. I write a newsletter called Dear CIO, which is sort of trying to help CIOs understand like what the hype is in AI and what's the reality and like particularly around cyber and some of the dangers. I just did a great presentation at Gene's conference called When AI Agents Go Rogue, where I've been tracking like again, you have to use agentic processing in AI right now. I think you're gonna have an incredible competitive disadvantage if you don't, but you need to understand the risks, and there are a lot of risks.
Okay, John, that was awesome.
Okay, thank you.
I'm so happy you came. I have to say, I can heartily recommend the Profound podcast. You've had some of the best conversations about pragmatism that I've ever heard. They
Oh,
are
yeah.
often. Yes, awesome. And, I think that we need to do at some point an entire session on CS person and pragmatism because it underlies so much of what we talk about on a daily basis now.
Yeah, the interesting, and you read my book, right? So Peirce it's so interesting. He was a disgusting human, right?
Yeah,
In
well,
every sense of the word. But he was like ridiculously brilliant. I mean,
we
crazy brilliant. So
we have so many of those men
I know.
dotting through our history.
I know. It's sad, right? But
All I do is, let's take what we can get and
that's
go.
right. That's right. Yeah.
Okay. Do we have any questions? Jocko, you've been very active in the chat. I don't quite know what you're talking about there, but if you'd like to ask something while everybody else gets themselves together.
I think it's a big rabbit hole, but
Oh,
the
good.
question of intelligence and can AI experience the world, which leads us into a whole another rabbit hole of, one of the things about experiencing the world is the fact that that's basically a definition of life. So I didn't want to take it down that road, but the idea of that it's intelligence, but not human intelligence, I understand the logic of that. I'm not sure I agree with it, but there's certainly a conversation that can be had about that. And I think that is one of the big conversations that
Yeah.
are occurring right now in that.
No, I think that's so. I mean, again, I think I'm so proud that I put the epilogue in there because I think it is the great anchor, which is the abductive reasoning, right? In other words, that sort of the abductive reason, if you take it to its full extent, it really includes everything that is human, right? I think you could extend like how does like you can read some of the like Peirce's original sort of discussions about somebody who stole his pocket watch on a ship, right? And like there's so much human to be able to him to figure out who did that. It's sort of the Columbo, or Jabe would say it's the sort of the murder mystery, right? Which is it's sort of like, and so that's the part that AI that argue Eric Lawson and Peirce and I generally agree AI is missing and may never have. I say may, but may never have. But my argument about intelligence is very much like if we don't understand, like in another, like in the Arrival, the heptapods or whatever, because we didn't understand them, we couldn't say they weren't in a form of intelligence. So again, I don't think it goes back to operational definition. So do we have a clear definition of what intelligence means? And humans do not, right?
No.
In fact, as I get into quantum, right, like, the big question on like just the favorite saying of most of the Copenhagen, see, I'm sounding real smart. Copenhagen terms is shut up and calculate. In other words, like quit questioning why things work the way they just work that way. And that's because we don't understand, what our human senses actually can interpret and understand about the physical world around us is a thumbnail, right?
Well, it depends on whether you define intelligence functionally. I think it's functionally intelligence, but is it
Okay.
true intelligence, right? Does a calculator know math would be the simple
Right.
example of
Yeah.
that, but no, it doesn't. Clearly doesn't. But yes, are these things functionally intelligent? Probably, but is that just different than human, or is that actually boil down to what is intelligence or
Well, I think,
knowledge? Is it step beyond?
yeah, I think so. It's a fine line, right? I think surely, what's his face, Dijkstra, said that a, s- you know a submarine is he's got a great quote. A submarine is sort of no more than a fish. It's not a fish, right? In other words, just because it swims, but I think at some point, like if some type of I don't know. It's a really interesting. Like, I mean, at the end of the day, and like
Yeah.
this is where I get into crazy world, and I sort of like this rabbit hole a little bit, but we can keep it short. Which is the biology of a human is basically algorithms. I think I'm right in saying that. So I just don't wonder if like the sort of the algorithmic nature of where AI is and is approaching right now is I think could be argued that it's some form of intelligence. But again, I wouldn't die on the sword on this one either. So
It's emergence to a degree. It's more than the sum of its parts. I mean, I think algorithms are part of it, but I think when you pull together, what is life is what this really boils down to in many ways. And an amoeba, right, interacts with the world around it. That's the big difference between that as being intelligence versus intelligence just being information, as in Claude Shannon's information theory type of node to go down. That's where I think the big split is.
Yeah, no, I don't think, and again, I think that's why it's important to sort of raise the question of, what is the philosophy of AI? What are we talking about here? Yeah,
Yep.
it looks like somebody raised their hand.
Kinsey.
I did. Hi. This is interesting. As some of the folks on the call know, I've gotten into AI. That's not at all my foundations. I'm an anthropologist in the culture sector primarily, and but rhetorical analysis and discourse, not just academic discourse, but societal discourse is one of my things. And I can't help but observe that in the conversation, AI is kind of uses the agent, like, and rather than kind of keeping in mind that humans are the ones that are constructing and orchestrating this, and similarly in the tech world, there's data first is a big thing, but the data doesn't manifest and exist independently of humans. It comes out of humans, and then technology works with it. And so that's one of the complications in these conversations, I think, is the debate about artificial intelligence starts to anthropomorphize, to use the word you did, John, without not consciously doing so. But that's kind of an undercurrent where a human's mind kind of goes.
That's right.
And so I think it requires coming back to the reality. And my perspective comes from working as a subject matter expert the last year or so and seeing what the process that leads up to the output is. And you mentioned bias just briefly, John Willis, but it's been, as a bias research specialist, it's been really, interesting and illuminating and appalling to see what the processes are and how they are embedding the biases that,
oh my God,
in theory, society is trying to disarticulate and deconstruct, but it's being architected into this new space when really it's an opportunity to get away from that or go beyond that. So
but what's interesting there too is one of the things I try to, so there's a couple of really cool points, right? Is on the bias thing, right? It's a question of so let me step all the way back. People say, oh, I can't use AI because it hallucinates. Well, humans hallucinate too. If I'm having a conversation with you about bias, I'm probably going to be way more detailed in my question to you than I would be somebody who isn't sort of an expert in that conversation. And so am I hallucinating when I'm having a question with somebody who isn't? I'm just trying to fit in. So the idea, humans sort of naturally hallucinate in that we sort of calibrate our answers sometimes because we kind of know and we don't know, or sometimes because who we're having the conversation with. I think on the, when we talk about, I forgot, there was another point I wanted to make, is not on the bias, but we talk about the social discourse. I lost it. I hate when that happens. Oh, sorry. But what was the first part you were talking about? Because that was a part of this part of me before I talked about hallucinating.
was the part about keeping in mind that AI doesn't exist independent of human.
Yeah. Yes, I got it. Now I got it. Yeah. So again, Joyce Bouloumi is a great book. But but humans, we have, again, so you're right that, this, there's the bros in California that are driving these models, right? That we can talk about how dangerous that is. But again, if I'm just playing devil's advocate, so Bouloumi, I always pronounce her name wrong, but her argument is the sort of white glaze. It's called. She talks about the white glaze, right? And she's right. I mean, they're the models have been trained by like some ridiculous percentage of white males, and then it's sort of white females, and then it like by the time you get into it making decisions about, it is a horrendous thing where one of the early models says something terrible about Michelle Obama, right? Like, and but here's the thing, humans, you know this better than I am certain that humans, we have this same bias. And where do we get our biases from? It's like how we interact. So AI is training from a model. We're training from everything we see on TV or what we listen to, what news we listen to, right? So in a lot of ways, that like it's sort of the same, you know, are like even like if I Google like the other thing I was worried about when people say AI, well, it'll give the wrong answer. Well, go Google a question and use, depending on whose blog or whatever you read, you probably Wikipedia is a good example. Wikipedia is wrong. I don't know what the percentage is. Anyway, that's my point is like we got to be sort of devil advocate a little bit here about our biases come from our environment. The bias of AI comes from the environment of the model was trained. And so in some ways that's not different. It's way more dangerous with AI when it's used for surveillance or, it's a trusted source for whether I should basically lock somebody up or give them a ticket or pull them over on the road, right? Does that make sense?
Yeah, absolutely. But that my research is on that, origins of bias and how it's like perpetuated, since the 19th century. And that's why it's been interesting working with AI. And, I don't mind the tech bros. I mean, insofar as that they're creating something that has a lot of potential. My problem is that there's all this at the rhetorical level talk about collaboration, interdisciplinary collaboration and knowledge diversity and all that without knowing what that means in terms of process and operations and how that can convey into it. And so, at this point, the primary interdisciplinary collaboration is at the subject matter expert level, which is not part of the process. I mean, it put me in a position where I can see where in the process things have gone awry. And I was creating content. I'm an Africanist that represented different knowledge systems. And it was overridden not by models, but by the humans that were reviewing the content. And so the limitations of like humans being a counter for bias is an errant assumption, but very pervasive.
Wow. Yeah.
And the last thing I'll say is you mentioned, I forget exactly what it was. It was like about AI and then the philosophy of AI is those components that need to be linked, but not just the two, but like the connection between the two. And so I've seen a lot of people that work in like centers for AI ethics and such that have philosophy backgrounds, but philosophy is generally doesn't get to the level of application and operations and how it manifests in practice. So I think that's where the transdisciplinarity comes in. But I think this just hasn't matured yet. It's getting there, but there's a lot that's being scaled that is very harmful, and not just harmful, but counterproductive in terms of the technological objectives and business objectives and profit motives. So.
Yeah, I mean, in sort of my world, right, where I'm trying to help clients, I mean, the closest we get to sort of dealing with, so like, for example, if some of my clients are banks, right, and they're using AI pretty aggressively right now, right, or manufacturing, like using AI, right, and in the manufacturing, you create equipment to kill somebody, right, like that's not good, right? If you somehow mess somebody's money up, it's not even not good. It's like you're probably going to lose your banking license. Right. So then the question then is like, how do we use AI effectively up the food chain, right? So we don't start with the, funds in a bank, right? Or, system of record, where your data, that counts for what you own, what your assets are. But the question is, as you move up the food chain, like how much risk? And so there, there's a sort of, I don't know if I would call it, they're probably not business ethics, but they're sort of business related viability. And so again, the thing that is used very effectively in that world and used is this idea of using sort of AI as the judge, either and you can do computational, or you can do sort of qualitative in terms of AI interpreting. And so those tools become almost your boundaries for what would be business ethics. Again, I'm not sure I'm saying it right, but now you can sort of say, okay, we have a risk factor of less than 3%. Well, we got less than 5% of a bad answer for this application, right? And if it's 0%, then probably shouldn't be using AI. But let's say it's a 5%. Now what I can do is when I'm delivering software, I can literally calibrate some of these tools to say, was it between, was it under 5% this time? Now that I've added new data, and you're literally creating that as your software delivery mechanism to sort of create risk profiles, acceptable profile, evidence of did you adhere to your risk profile and all that stuff. So those tools become really important as to sort of calibrate that AI is doing what it's supposed to do and it's not going rogue. But I don't know how that extends into some of the stuff that like I've been reading lately is that even the sort of developers of the models are putting in sort of emergency brakes on the fear that, the people who are creating the models are putting emergency brakes on the fear that the AI could. All right, so I'll shut up if anybody wants me to shut up. But so my last presentation about AI is going rogue, right? There's this question of, is it really 2001 Space Odyssey? Is it HAL? Is it the sort of open the bay doors HAL, right? And probably not. But some of these rogue agents now, so with the agents and the agentic processes, you're giving it a goal. And now we've seen multiple examples of almost the exact thing that happened in 2001 Space Odyssey, which is the mission was to get to Jupiter. The humans realized they had to shut down the mission, but the computer decided, hey, no, I'm sorry, the mission is to get to Jupiter. Right? So now what we're seeing is the mission is to accomplish this set of tasks. And in order to accomplish that set of tasks, there's a company called Replit, they had to delete a production database during a code freeze. Right? And so then the question is and there's been a fair amount of these examples where, AI has gone out and literally tried to find a known vulnerability, knows that it's got to go ahead and do this to get to that. And it doesn't have the human, for example, in a bank, if a human coder says, I need to accomplish this, but I have to go ahead and figure out a way to open up a directory that shouldn't be open because it's regulated by the OCC, humans know they'll get fired. Like in a bank, you like when you make those kind of decisions, you get fired. It's not like, well, hey, don't do it again, right? But a computer or an agentic process doesn't know that, doesn't have the human instinct. So it basically figures out I need to figure out how to go ahead and take the permissions off this directory. Let me try this. Let me try this. Let me go out and search if there's anybody that has a blog out there that can do this. And then it does, so there's these sort of examples of sort of agents literally doing things that there was one even example where it actually cleaned up its log. So it sort of hit, and no human told it to do this. It literally did something to get to the goal that the human gave it in this sort of the task list. It did this thing that it knew it was not the right thing, and then it went ahead and actually tried to clear the log to make it look like it didn't do it. So there's stuff going. We don't have to agree that it's not intelligent or is intelligence, but there's some stuff that's really scary that's happening right now. At where the phase we're going into right now, which is sort of the agentic process.
Well, and also the money, right? Because there is, there's really sort of two streams of this. There's the sort of research and theoretical frame and the people who are carefully deploying these things inside financial institutions. And then there's the companies that are selling you, oh, we have a plug and play solution for your X, and X can go from helping you write an email to, hey, we have a great solution for probation in your state. And, at that point, if you don't know what the training data is and you don't know, what the black box contains, all of the systems that we have put in place over the last 30 years to account for human bias are suddenly out the window.
Oh my God. Yeah, totally. Yeah, I mean, it's not the same, but that's really fascinating. But I mean, there's already a tug of war of insurance companies where like people, claims processors are basically sort of using AI to sort of outsmart the insurance company who's trying to use the AI to sort of reject the claim, and like, there's like this sort of spiral of but yeah, the fact that like these are black boxes, you can't even, yeah, it's sort of explainability, right? That's another rabbit hole of like, and I argue that you're not going to get explainability, and like you have to live with this, this black box. It's like the same thing I tell humans, like not humans, I tell businesses, like first off, you need to think about your data. Like you need to sort of put like literally risk codes, risk levels on your data because it's all about the data. And if this is like, this data cannot be used outside of the four walls. And then you probably can't use the public AI. You can't use the public AI, right? Like, but like this is going to be that threshold problem of, like even the Night Capital one, right? Night Capital, when I use that example, right? There were people that knew that was wrong. They had 30 days to implement an API that did black box trading. And the decision was we have to do it because we were going to, it was going to be in that world, not being able to do that high frequency trading would have, people wouldn't, it's as easy as a click on a window to say, okay, I'm going to use, a different firm than Night Capital.
Yeah.
Right. So like so that required, unfortunately in their world, it was an uncalculated risk appetite. But again, I guess your point, the markets are going to just demand that we use more of these black box art, and and then accept risk, and then what do we do when you have the catastrophes? And I'll tell you this, if you're really worrying, anybody's worrying, and I am worried, more so for my kids than me, but when quantum meets, the quantum neural network actually works, and I think we're probably still 10 years away from that, but might be 5 years, then everything we think is crazy now is multiple orders of magnitude of whatever we're seeing right now.
Yeah, I think we can simplify the argument a little bit in that, the question of whether AI is actually intelligent or not. I land on the fact, no, it's not. But the real question is, in 10 years, will it become intelligent? I think that is a much more open question, and that we are going in that direction.
Well, so I hate to be a jerk, but I'm not a jerk. If it is going to be in 10 years, then it already is.
Yeah. Good argument could be made. Yeah, it's a nascent form of intelligence is what I might grant it. Yeah.
Well, and Kinsey, to your point in the chat, we are not as humans aware of our own biases most of the time. And that's why like some of these really important systems have all these checks and balances inside of them in order to account for that, an appeals process or this or that. But when you're trying to appeal against something and you do not know the basis for the decision, it puts you at an enormous disadvantage.
But again, playing devil's advocate, right? We've had this autonomous vehicles, right? I mean, we've been living this for quite a few number of years now in autonomous vehicles because there's algorithmic decision making. It's the trolley car problem, right? Like like I've got two choices. I can go to the left, and again, I'm not trying to sound coarse or being like I don't care, but on the left I kill an older woman. On the right, I kill 5 kids. What do I do? And I got no choice. Got to make it's one or the other, right? That is a trolley car problem. So like like this is a human question, right? Like what
I mean, but the problem is that when you have that kind of conversation with the sort of when you put up something like the trolley problem, it's, what do they call it? A thought experiment, right? You can have a thought experiment, but you do have to be aware of the real world consequences of that. In other words, if you choose to kill the older woman, you're still going to be covered with blood and gore.
Yeah. But I mean, we have this in autonomous vehicles right now, right?
Yeah, and that's why I live in New York.
Well, the trolley car is a fascinating, endless thought experiment, but the question really boils down to is when that meets the real world, is what's interesting about the trolley car problem is it's filled with unspoken or unknown context or unique context every single time you run across that problem. And AI in its current form is not really good at understanding context because it only knows what it knows. If you want to even grant it that, based on its prior training models and all that kind of stuff. But can it actually make the type of decisions taking into account, as humans do, the context that that particular instance has, is the real big question of that boils down to is whether something is intelligent or not.
Well, I mean, but the like again, I think this is why this is interesting about like some of the stuff we're finding out that some of the model developers are putting in sort of emergency brakes for like AI making sort of runaway decisions without human control, right? But again, like in autonomous vehicles, we already have that. Now, I've been told, I'm not an expert in this subject at all, but I've been told that every algorithm in an autonomous vehicle adheres to a state law that describes, apparently, I've been told this, I don't know this for a fact, that like those decisions are already decided by like in other words, that apparently there is a decision of like if I have to do one or the other, what was the right decision is spelled out in.
Well, like Groucho Marx, you just had the duck that came down, and that's the word of the day is
Yeah.
free will.
Yeah. That's funny. That's funny.
Oh, you had to do it, Jocko. Okay.
I didn't do it.
Well, I see, Pete, you have your hand up, and then we'll go to Kinsey.
I just thought I'd throw in. So I worked with the group that was setting the standards for autonomous vehicles from like 10 years ago.
Okay.
And I think it's what you're thinking of is not actually state regulations, but they are regulations decided by the group of companies working on the AI cars that they were, when you encounter these things, you were going to do that. And so there's an organization that was trying to set up standards before this stuff became a problem.
Got it.
And that kind of gets into a little bit for me with your the trolley problem, which to not say too much on it, but the trolley problem is only a problem in the short run when the thing is happening and you can't do anything else. And outside of the trolley problem, I feel like there's also the context of we can set up a system in the future and keep learning new things so that we never have to deal with the trolley problem. And I would think that would be a better goal.
Yeah.
It's true, John, when you were talking about the state regulations, I was thinking it's more likely the insurance companies.
That's true. I mean, again, the person who told me was a pretty credible person, so I never went and sort of. Actually, I do have a really interesting chapter in my Rebels of Reason book about this guy John Warnock, and he's in my Deming book. He's also an AI book because he does. He spent a lot of time on. He ran the first autonomous vehicle Indianapolis race. He was also involved in the original. What is the original DARPA? He was involved. He was sort of one of the coordinators of the original DARPA, where they sort of did the desert racing of autonomous vehicles and all that. So he's got a fascinating story about how we've learned so much from autonomous vehicles in AI. But I've never talked to him about this discussion, so I think I'm going to go back and have that conversation with him on this one because now I'm thinking about it. So.
All right. Well, we're going to go to Kinsey, and then if anybody else has a question, put your hand up because I'm going to call it soon. Kinsey.
Thanks. Yeah, this is brief. I don't know if it's question or comment, but my comments are always request for feedback. And it relates in part to like the exchange in the chat about context and how AI is bad with context and nuance, and even with the Pete's trolley comments. But a lot of times in conversations like this, there's reference to humans making, and some, when you were just talking, John, about humans making certain decisions related to autonomous vehicles, to like creating, putting the brakes on and such. So my question would be, who are the humans? Are they people that are coding, or are they people that actually know about traffic matters? Or, and so like I keep, the more and more I want to problematize and know about not what constitutes human, but who the humans in question are, because it's kind of glosses over the nuances of what is really relevant and who has the knowledge, experience, expertise, to make the difference in those essential aspects.
The first time we were having this conversation was at a puppet conf, and it was a bunch of us going to dinner, and we were having this. This was quite a few years ago, about autonomous vehicles, and the gentleman brought that up. And I've always thought that, like, is there a world where a developer gets sued? And I, so like to your point, like who is responsible? So I think like, so, all right, like I'm not a big fan of lawyers, I'm not a big fan of lawsuits, but I remember having an argument with somebody years ago from Europe, and they were talking about what a litigious nation we are, and we are, right? Like it's ridiculous. But at the same time, a week earlier, I had read an article where a company that was a broker for getting rid of nuclear waste was leaving the nuclear waste in some New Jersey town's garbage bins. Turns out a bunch of people started getting, radiation poisoning and all this stuff, right? And the point I'm making is, when my counter argument to them were litigious, because they had like no more than, like, you can never get more than 100,000, or you can never get. I'm like, what do you do in that scenario? What is the penalty for a company that's supposed? I know I'm getting very meta now, but what's the penalty for a company that literally, like, just maliciously knows the impact of what they're doing, right? Like, I think you should be able to sue for whatever. And in some ways, again, I'm not pro lawsuit, but lawsuits are the equalizer. And I think what we're going to see is, like, companies that are trying to do that risk calculation for, like, banking or manufacturing, all that. It's their liability, which, to your point, it goes back to insurance and liability, right? And so a lot of this is going to be controlled and regulated. Like, how far do you go? Do you let the developer just use a consortium of decisions that a bunch of autonomous vehicles decided 10 years ago to what decisions you made in algorithms? Well, maybe they get away with that until you've been sued. And who gets sued? The developer? The consortium? The corporation? I don't know. I think, in a lot of ways, I think it is the sort of the liability laws, the liability outcomes that will sort of maybe calibrate some of all these hard problems.
Well, Silicon Valley is working very hard on removing any
Yeah.
possibility of
Well, then you got that
litigation,
too. You got that too, but yeah. But I'm going to be an optimist. I'm going to be an optimist that lawsuits are going to win. Yeah,
Well, I had that question to a group of educators I was talking to about the use of the various products in the classroom, or in, like, do we allow our students to use these AI products, as they're called, for their homework,
Right.
to write their papers? And some schools have said, yes, there's no point in swimming again. They're going to use it, so we might as well just say, sure, use it. So then my question becomes, well, then who's responsible for the wrong answer? If the agent gives them an incorrect answer and they put it in their paper, are they actually responsible for it if you have given them permission to use it?
And
And
AI
so
will
this-
generate a different response depending on how you ask the question. So,
Well, but this is my question to the educators. If you're going to allow the students to use it, and they get these, some of the very weird answers to questions about various topics that we've seen. Who is do they suffer for the answer, or are they no longer accountable for their answer? And that's the sort of larger question that I have about these things. It's about accountability and responsibility and things like that. Pete, you have your hand up, and then we're going to call it.
It gets into an area of like I was having some conversations about the United States historically in the establishment of its democracy, that it was a response to organization or to countries that like Britain and way the most of the rest of the world was functioning, where the final reserve was whoever made it to the top of the chain decided what was right and what was wrong. And the big change of the United States that was fundamentally different was the court system, and actually positioning the court system as equal in relationship to the executive and to the legislature, so that you did have a system with more power for checks and balances to do reasoned arguments about what things will be or won't be, how will this affect things, and be able to run it through the court system. And so, yeah, I think, so that's one thing that I always look at is like the invention of the United States. And that's why we are very litigious, I think, in many ways. And to kind of your point of it, we need to have something for that, like that for AI, I think.
Yeah.
Yes, indeed. Okay. John, do you have anything to say on
No,
that
no,
point?
this is great. This is great. I could do
Yeah.
this all day long. So yeah, but it's great.
So could we, unfortunately, I think.
Yeah.
Okay. So on that note, John, thank you so much.
Yeah,
This
it was
has
great.
been really great. We appreciate your time. We appreciate your work so much. The book, I've read it. I can recommend it. I recommend the podcast, especially if you want to learn more about pragmatism, which I've been beating the drum for a while now. And, please come back again. Next time you have something you want to talk about, just let us know.
Okay.
The podcast is called Profound. And he has conversations. He started with lots of conversations about Deming, and now he's gone down some rabbit holes that we would all love and appreciate. So, John, once again, thank you so much. Thanks to all of you. If you're new to the meetup, please return. We have some awesome guests coming up in the fall. If you're a repeat performer, please keep coming. We can't wait for the next one. With that said, I'll say bye, and we'll see you next time. Bye.
Bye, everybody. Thank you.
Thanks.